Okay, we just finished the network architecture part. Then the next part will be the air interface. So we want to have this advanced capability, right? Through two ways. One way is from the network architecture. The second way is for the new technologies on air interface. Okay. So second part of the section 2, new air interface. For the new air interface, we introduced a lot of the new technologies like large bandwidth, okay, to support broader throughput. Okay. High-level modulation. Now, this is to provide more bandwidth. Okay. And the massive MIMO. This is to provide better coverage and also better capacity. And the polar or LDC coding, this coding can provide us more efficiency. And FOFDM and flexible frame structure, this can provide more spectrum efficiency. And the uplink and downlink decoupling can provide better uplink coverage. Okay. We will elaborate these techniques one by one. And with these technologies introduced, it can satisfy more requirement for different services. For example, some is for broader bandwidth for mobile internet, eMBB, and some may provide more number of connections or less latency, like suitable for IoT. Okay, let's start with first one, large bandwidth. The 5G's bandwidth is much broader than 4G. Okay, and this is 5G's radio carrier spectrum. 5G can be deployed on sub-6G or millimeter wave. We have studied this in previous class. This below 6 giga is called sub-6G. Sub-6G include two parts, sub-3G and C-band. It's better to do this way. FR1 and FR2. This one is a FR1, and this one is a FR2, FR1 and FR2, frequency range 1 and frequency range 2. And the frequency range 1 means sub-6G, and frequency range 2 means mm wave, millimeter wave. And for sub-6G, also two parts, sub-3G and C-band. Sub-3G is just this one, below 3G, sub-3G. And for C-band is just the other part, between 3G and 6G is a C-band. Very, very popular frequency is using this one, 3.5, okay, gigahertz. It's in this range, right? Between 3 to 6. So it's C-band. Got it? This is a C-band, okay. C-band. So it's very popular worldwide roaming frequency band. And the frequency 2 is a millimeter wave with very high frequency. It can be from 6 giga to 80 or 90 gigahertz. There are plenty of available resources. So these are the spectrum of 5G. That is the spectrum range, and those spectrum range are used by the carrier. You can see LTE carrier is from 1.4 megahertz to 20 megahertz. 20 is the maximum bandwidth for LTE carrier, 20 megahertz. And for 5G in frequency range 1, okay, we have such options. It's 5 or 10 or like this. The maximum is 100. Now compare them, okay. 4G maximum bandwidth is 20 mega. hertz. And for 5G, the maximum in FR1, okay, this is a sub 6G, okay, sub 6G is 100 mega, 5 times of it, okay. And in FR2, this is the millimeter wave, okay, millimeter wave, the maximum bandwidth of a carrier is 400, okay, megahertz. It's very big, okay. So this one and this one, we have large bandwidth. Of course, it can provide us quicker speed, okay, higher speed for the broadband access, okay. So this is about the large bandwidth. These large bandwidths are provided by C-band or millimeter wave, okay. So let us first see the C-band, okay. C-band is from 3G to 6G, okay, 3 gigahertz to 6 gigahertz. It has proper coverage and with proper capacity, proper coverage with proper capacity, and it's suitable for coverage layer for the 5G. But it has a shortcoming. The shortcoming is that the C-band uplink and downlink is not balanced. See, the blue color is for downlink coverage, and the green color is for uplink coverage. You can see in the urban, okay, no matter in urban with what data rate, the 10 and the 1 is 10 megabit per second, 1 megabit per second, okay, 50 mega and 5 mega, okay, this is different speed. And this one is for downlink, and this one is for uplink. For downlink, 10 mega, okay, uplink 1 mega. Downlink 50, uplink 5, like this. You can see under such situation, the downlink coverage are always much longer, much farther, okay, than the uplink. It's more than 2 times. Take this as example. In a very dense urban area, with 50 megabit per second for downloading, with 5 megabit per second for uploading, in this case, our downlink can cover 250 meters. 250 meters. Okay. But uplink can only cover 70 meters. 70 meters. And finally, which will be the sales coverage? 70. Because we need the downlink and uplink both. Okay. The smaller one will be the final coverage. So we need to solve this problem to enhance the coverage. Then this technique is introduced. That is called uplink and downlink decoupling. Uplink and downlink decoupling, also called SUL. SUL, it means supplementary uplink. So what is the SUL and what is it used for? It is useful to enhance the uplink for C-band. Look at this picture. The yellow color is the coverage for uplink for C-band. And the green color is the coverage for downlink in C-band. If a mobile is in the range in the yellow color, there is no problem. It can work on C-band, on both uplink and downlink. But if the mobile comes to the green colored area, then downlink on C-band is no problem. But uplink is not reachable because uplink can only reach this range, So the uplink and downlink has a gap around 14 dB, a big gap. So in this case, the uplink is not reachable. So this side of this part of area, we cannot provide service. How to solve this problem? We use this SUL, also called uplink and downlink decoupling. We can use another frequency which has less loss to compensate the difference between the uplink and downlink. For example, here, okay, This is the coverage for C-band for uplink. And when we are in this range, we can use the C-band for both uplink and downlink, no problem. And if we come to the area which is outside this yellow area, it means downlink is okay, but uplink is not reachable. In this case, we can use the uplink in another frequency, using this 1.8 gigahertz. This has much less loss comparing with this 3.5 gigahertz. Okay, so downlink using 3.5 gigahertz, uplink we use this 1.8 gigahertz. It has less loss. Then in the blue color, it will be the uplink. Okay, coverage using 1.8 gigahertz. In this case, uplink is enhanced. Okay, but you can see that uplink and downlink is not in the same range. We can say that uplink and downlink frequency are decoupled, in different range, decoupled. So we call it uplink and downlink decoupling. In this case, uplink coverage is very much enhanced. Okay, so this is about the uplink and downlink decoupling for C-band. About millimeter wave. Millimeter wave is of very high frequency. Let's take the 28 gigahertz as example. The higher the frequency is, there is more loss. Now, the more loss, and there is. Let's compare about the path loss. This is the path loss on C-band, and this one is the path loss on MM wave. They have a great difference. Okay, 18 dB, right? This one, 18 dB difference. Very much loss. So the coverage of MM wave will be very weak comparing with the C-band. Okay. So the MM wave cannot be used for the main coverage. It will be used for some special scenarios like hotspot, used for CPE, okay, FWA, or used for the self backhaul in some these scenarios. Okay, it cannot be used for the main coverage because of only with a very small barrage, okay, the signal will become very weak because of this path loss and penetration loss also very much. Okay, penetration loss, you can see that this one is 5 dB more and this one is 11 dB more. So no matter for the path loss or for the penetration loss, MM wave, there are more loss, so it has very much low signal. So only used for some supplementary coverage, okay, not for the main coverage. But for MM wave, we have plenty of free resources that are available. It can provide a very much broad bandwidth supporting very high speed of the throughput. So in hot spot, it will be very good supplementary coverage. For example, in some shopping mall, okay, at some business center, okay, we can use this one, millimeter wave, okay, for the capacity. So that is about the broad bandwidth. Okay. Second, for the modulation. For the modulation in the 5G, a new modulation for uplink is introduced. Is this one? Okay, this is for LTE. This is for 5G. Others are the same. Just for the uplink, 256 QAM. This modulation is introduced to provide more throughput. The higher the order is, the more the throughput is, right? Okay. You can see this is the 250 QAM, and this is a 64 QAM. Compare them. This is much more dense, Okay, it can carry more data. But it's very hard to distinguish them. It's easy to make mistake using this one. Okay, this one it is not that easy to make mistake for every bit, but it can only carry less data. So you can see that This one can only be used near the base station. When the signal is very good, we can use it to carry more data. Our communication can be faster. Okay? And when we are moving away from the base station, signal become poorer and poorer, then we have to use lower level of the modulation. Okay? We can keep the communication, but we cannot keep the speed. Speed will be lower. Okay? So it's about the modulation. 256 QAM is introduced, high order modulation introduced in 5G uplink to support more throughput.